rational equations. Everybody loves to hate rational equations. What is going to save you is knowing your domain of your rational equation before you even get started. So what exactly is a domain? Well, if you remember, your domain is the locations where your equation or graph do not exist. Now, when we're dealing with rationals, the biggest thing that we have to remember is we have to remember that rationals always follow fraction rules. In other words, the biggest fraction rule that we have says you cannot have 0 in the denominator. So we have to follow that rule, and that's where your domain kind of comes from. So what we do is we've got this rational here, and in order to find the domain, what we essentially need to know is in this denominator part, what values would cause 0. So what you're going to do is you are going to set the bottom not equal to 0 and solve for the variable. That's the step that we have. So our bottom is t cubed minus 4t. I could care less what the top is. I want to take the bottom, which is t cubed minus 4t, and I'm going to say this cannot equal 0. And so I need to know if there are values of t that when input here would give me 0. So we're going to go ahead and solve. The first thing I would do is I would distribute out or pull out a t. So this becomes t times t squared minus 4 cannot be 0. Now I have t and I have t squared minus 4. So both have to be set not equal to 0. And then I have the t squared minus 4 can't be 0. So the first half I've already solved. Second half here I need to solve. So this becomes that t squared cannot be 4. So t cannot be plus or minus 2. So I now have 3 values that my denominator cannot be. Well, when we write domains, your domain is always an interval. So in order to write the interval, essentially what we say is we say d, and then you put in your little dots, and then we're going to start. So we're going to go from negative infinity up to that first smallest, most negative section. So I have 0, I have positive 2, and negative 2. So the smallest, most negative value I start with is the negative 2. Then I need to put in my u, and I need to pick up where I left off. So I left off at negative 2, and I'm going to travel up to my next smallest, most negative value, which is 0. Then pick up where I left off and travel up to the next, which ends up being 2. Pick up where I left off and continue traveling along. Well, in this case, we don't have any other values but positive infinity. So this would be your domain. Now, I can give you a little hint or trick so that you know if you have enough intervals. Okay, so here's the trick. The number of intervals is always 1 greater than the power. Okay, 1 greater than the power. So if we look, this was our denominator. So what you should notice is that here I have a power of 3. So in this case, I have my power equals 3, which means my number of intervals is 3 plus 1, which equals 4. So if I look, I have 1, 2, 3, 4. I have all the intervals I need. I didn't miss any. I didn't skip any. I'm good. Okay? So now that we got the domain out of the way, we can look at 2 different examples of being able to solve rational equations. So as soon as we get started, the first thing that you want to do, okay, so the first thing that we need to do is you need to factor any quadratics into their parts. So we want to factor any quadratics down into their parts, and the reason for that is to make it easier in trying to identify your least common multiple. The second thing you have to do is you have to do just that. You need to then identify your least common multiple. While identifying your least common multiple, you also want to identify the domain. And the reason for that is because once you find your solutions, you have to check and make sure that neither one of them violate the domain of your radicals or rationals. Sometimes when we're solving, we end up finding what's called an extraneous solution, essentially meaning that that value has violated your domain and thus cannot be used. Okay? So when we're talking about rationals, you might only have one solution even though you have the potential for more. Okay? So you have to identify that domain. Then the third thing that you're going to do is you want to look at multiplying the rational equation by that least common multiple or least common denominator, however you look at it, to cancel the denominators out for solving. In other words, because this is an equation, we can simply multiply the expression by that least common denominator or least common multiple, and we can reduce or remove all of the fractions and just make them into a straight equation. Okay? So essentially, after you do that, your fourth step is that you are going to solve for the variable and then check all solutions against the domain. Okay, so those are the steps that you are going to follow in order to make this work. So let's go ahead and take a look. So the first thing our step was to factor any quadratics down into their parts. So we have this problem here where we've got x over x plus 3, and then we're going to add that to 1 over x minus 1, and we're saying this equals 4 over x squared plus 2x minus 3. So in this case, we have to factor. So we are going to factor this down into its pieces. So we know that x squared can break into x and x, so this becomes x and x. We know that this back term is negative, so I have one positive and one negative factor. I need factors of 3 that give me a positive 2. Well, the only factors of 3 that I have are 1 and 3. My 2 is positive, means the bigger factor is positive. So this becomes 3, and this becomes a 1. Okay. Once you have factored it down, that next step is we need to identify that least common denominator. So here we're going to go ahead and be able to state that the least common denominator here is going to be x plus 3 and is going to be x minus 1. Okay. Now, with that, we also need to identify that domain. So in this case, when we're looking for your domain, we know here that if you look at the denominators, I have x plus 3, x minus 1, and that's the only things I have. So in this case, I know that I have that x plus 3 cannot be 0, and I have that x minus 1 cannot be 0. So in this first case, I have that x cannot be negative 3, and I have that x cannot be 1. So I'm going to keep these domains in mind when working the problem out. Once you know that, the next step is you have to multiply the entire equation by that least common denominator. So let me rewrite the equation here. So we had x over the x plus 3. We're adding that to 1 over x minus 1, and we said that equals 4 over the x plus 3 times x minus 1. So what we're going to do here is we are going to multiply everything by that least common denominator. So we're going to multiply by the x plus 3 times x minus 1. Alright, so if we look at this first fraction, we will multiply by my LCD, and what happens is the x minus or plus 3 goes away, and it's going to leave behind x times the x plus 1. Now let's look at the second one. Again, I'm going to multiply by this least common multiple. Okay, so again, if I look, this whole thing is times x plus 3 times the x minus 1. So in my first one, that went away. In my second one, notice it's my denominator goes away and leaves behind plus 1 times the x plus 3. Now if we look at the back end, again we're doing the x plus 3 times the x minus 1. And its denominator, if you look, the plus 3 goes away, the plus 1 goes away, and leaves behind the 4. Okay, so we multiplied everything. Notice my equation has 0 denominators. Okay. So with this, what we have to do now is we have to work on solving our equation. So here, again, we are left with x times the x plus 1 plus 1 times that x, sorry, plus 1, I think I meant minus 1, plus the 3, and then is equal to 4. So we have to distribute the x through. Okay, so we're going to distribute the x through my terms. Then we have to distribute the 1 through the terms and then solve for x. So here we're going to have x times x is going to give us x squared. X times -1 gives me a negative x. X times 1 gives me a plus x. X times 3 gives me plus 3 is equal to 4. I need to combine my middle terms here because I'm going to combine my terms. And I end up with x squared plus 3 equals 4. Take this 3 and move it to the other side. I get that x squared is equal to 1. So here I end up with x is equal to plus or minus the square root of 1. And the square root of 1 is 1. So this really says that x is equal to plus or minus 1. Now, notice that also means you could write them separate. So x equals plus 1 and minus 1. Now if you look at these, you have to remember way back in the beginning, we found the domain. And the domain here says x can't be -3, x can't be 1. In this case, if we look at it, I'm saying 1 and -1. So what we have here is that by the domain, x cannot equal 1. Therefore, we have only one solution, and that is that x equals -1. Alright, let's do another one for good measure, just to make sure we're all on track. So the very first thing we have to remember, again, is that anything we have, we need to factor. So this is going to factor down into its parts. So this is going to be a t and a t. My sign back here says I have one positive, one negative. Factors of 6 that give me a positive 1 means I'm going to have a 3 and a 2. Then the next thing I have to do is I have to identify my least common denominator. In this case, we're going to end up with x plus 3 times, or sorry, t plus 3 and t minus 2. And then on the other case, we also have to identify your domain. And in this case, your domain says that t plus 3 cannot be 0 and t minus 2 cannot be 0. So when we solve, we find that t cannot be -3 and t cannot be 2. So here we want to go ahead now and we actually want to set up to multiply. So we have our equations. We've got 5 over t plus 3 times t minus 2 is equal to 2 minus, and I've got t minus 3 over the t minus 2. I am going to multiply everything by the least common denominator. So I'm going to multiply the first term by t plus 3 times t minus 2. I'm going to multiply the next term by t plus 3 times t minus 2, and the last term by t plus 3 times t minus 2. So if we look at what happens with this first fraction, notice the t plus 3's go away, the t minus 2's go away, and the only thing that's left behind is the 5. So this becomes 5. In my second one, I don't have any denominators, so this becomes 2 times my LCD, which was t plus 3 times t minus 2. In the last one, if you notice, my denominator is t minus 2, so that goes away. Leaves me with subtraction, and in this case I'm going to put this t minus 3 in parentheses because I have to apply that subtraction to it, and I have not done that yet. Now the other thing that was left was the t plus 3. Okay, so I have multiplied through. Now that I've done that, I need to start working on simplifying. So here the first thing I need to do is I need to combine. So this is going to be 5 equals, I have this 2, and I have to FOIL, first, outer, inner, last. So this becomes t squared plus t minus 6. Now, I have this subtraction, I haven't done anything with it yet, and the next thing I need to do is I need to combine the back half. Again, you're going to FOIL, so you're going to end up with t squared minus 9. Continue reducing. This is still 5 equals, but now we're going to distribute the 2. So we get 2t squared plus the 2t minus 6, and now we need to distribute the negative. So this becomes minus a t squared plus 9. Continue reducing. 5 is equal to t squared plus 2t, and then I have plus this is a 12. 2 times 6. So notice, mini aside here, always be double checking your work as you go. So what I saw is that when I distributed my t, I classically forgot to multiply this last term, and that was going to mess up the rest of my problem. So always make sure that you're glancing at the work above to ensure that you did not make any mistakes. So here, negative 12 plus 9 is going to give me a negative 3. And then I can go ahead and I need to take this 5 and move it over. So I get that 0 is equal to t squared plus a 2t minus 8. In this case, I need to solve for t. So again, I can factor it down into its parts. So I get t and t. My back sign is negative, so I have one positive, one negative. And I need factors of 8 that give me 2 as a result. So I've got plus 4 minus 2. So here I have that t plus 4 equals 0, and t minus 2 equals 0. So in this case, we have t equals negative 4, and we have t equals 2. Now just like before, if you remember, we did our domain, and our domain said that t can't be 3 and t can't be 2. So if you look at your solutions here, t negative 4 works, but here, this one doesn't work. We cannot use this. And the reason for that is because this one fails the domain, which means the only solution we have is that t equals negative 4. So if you have any questions, please let me know. Otherwise, there's a couple examples that will surely or hopefully help you with understanding and practicing using rational equations. So again, I hope you enjoyed. If you feel the need additional examples or have additional questions, always forward them on. Otherwise, I look forward to seeing you next time.